So that just eliminates a bunch of bugs right out the get-go and makes development faster. And I'm afraid I'm using too many terms.
Well, no, this is great, and it's hilarious. It's like people just tuning in here. We're like, wait a minute, is this a fab shop owner? What's going on here? Welcome to the Next-Gen Metal Fab podcast. I'm your host, Tim Heston. In each episode, my co-host, Oshcut's Caleb Chamberlain, and I will bring you conversations about what the future could look like for precision sheet metal and tube fabrication.
Don't miss your chance to see the latest in metal fabrication solutions at the Fabricators Technology Summit, August 20th and 21st in the Chicagoland area. This exclusive event, hosted by FMA, offers opportunities to visit local shops, see the latest equipment in action, and network with others in the industry. Visit fmamfg.org for more information. And now, back to the episode.
Hello there, this is Tim Heston, and welcome back. This time we'll be chatting about software that writes itself. Caleb recently submitted a column on that very subject and how dramatically code has changed over the past few years and what implications that might have for the fab shop of the future. So Caleb, just kind of bring me through your software journey at the shop. What was it like when you launched Oshcut several years ago, back in 2017, I believe?
2018, yeah, middle of
2018, yeah, 20 even more recently, 2018. So kind of bring me through, the aspects of software back then, and then your journey into actually, handing that software coding off to other folks. Then you're recently getting back into it, and you're discovering something new. So just kind of bring us through that story.
So two things have changed. One, our software stack has changed, and the software stack refers to everything from, what the customer sees on the front end to the back end, the database, and all the technologies that connect everything together. And so there's a lot of different ways to write software. So our software stack has changed in that timeline in very positive ways. And the second piece has just been AI. And I know that's such a loaded isn't the right term. What's the word for it? It's very, a trendy term, AI everything. But I was surprised because we've started using some AI tools that have actually completely changed the coding experience, and we're just getting started.
Yeah, bring me through that. Well, how have things changed?
Yeah, for starters, so you hear this word tech stack all the time, and if you think back to I have an article on this as well. Like in the old days, you would wander into like an office store and there's a bunch of software and boxes shrink wrapped on the shelves, and you'd buy it and install it, and that's that. Software is not that way now. Now everything is online. All your data is hosted online, a secure, safe environment with backups that you don't have to worry about. And then the software that you interact with is plugging into that, usually through a web browser. And there's a back end that handles all of the communication and updates and that sort of thing. So it makes the software very lightweight, agile, continuous, improvements and deployments and bug fixes get released. And from the software developer perspective, it's an easier to manage supply chain. And then from a user perspective, you just get nice, fast software. And it is actually just a better way of writing tools.
And just to give some folks some context, if folks are not familiar with Oshcut, it's what I like to call a web-based shop, where you can upload your 3D file, gives you an instant quote, gives you a simulation of that file, correct? And it's that custom interface. It's not off the shelf. You've actually developed in-house software, like a few other shops have around this country and also in Europe. And it's just this customized approach. So you're developing custom software in-house. This is not off-the-shelf software. So traditionally, kind of bring me through back in 2018, 19, 20, when you were just getting off the ground, what the bug fix process was like. It's still an innovative process, because you told me stories about how operators could say, hey, could we have this or that? And you'd be able to write it quickly. And that's just great. But now you kind of bring me through now how that's even accelerated even further. So just kind of bring me through that.
Yeah, a lot of it's quality of life. One of our developers calls like coding in raw JavaScript. JavaScript is the language that your browser runs. So anytime you use a web app, and most websites at all, it's running JavaScript in the background. He said coding in JavaScript is like coding blindfolded. And it very much is the case. So we moved to TypeScript, which is the superset that adds a bunch of additional type safety and checking, and it tells you if you do something wrong, syntactically or referencing something that could be a type you don't expect or whatever. So that just eliminates a bunch of bugs right out the get-go and makes development faster. And then on the back end, every time you pull something into the remote repository, which is hosting your code, it actually runs a bunch of tests, and we have that set up on GitHub. And I'm afraid I'm using too many terms.
Well, no, this is great, and it's hilarious. It's like people just tuning in here. We're like, wait a minute, is this a fab shop owner? What's going on here? Just insightful and indicative of the fact that, hey, guess what? It used to be, hey, everybody's in sales. Well, now in the future, everybody's going to be in software. But kind of bring me through kind of for a non-software audience. All right, the implications of, all right, a laser cutting operator sees something on your software screen, says, all right, the Nest says something about this sheet, some problem happened in laser cutting or forming or what have you, and then you go and fix it and kind of bring me through that process, rooted in the metal fab terminology.
Yeah, exactly. So in fact, we just had this problem fairly recently. We pushed a new update and it called what we call a regression, which means the code was working before, and then we pushed an update somewhere and it broke something we didn't expect. It's a common thing. Mm-hmm. So you see a regression, and the developer can pull it up and see what's going on. So with these new automation tools on the software end, once we have the fix and it's tested and gets merged into the repository, which holds all the code versions, GitHub Actions will actually take that code and just deploy it automatically and instantly. So it tests it to make sure it passes all the tests we've set up, and then it just pushes it to production, just like that. Right? So that manual process I described before is just so much faster. The reason that this is all really interesting, and I've barely scraped the surface of all the nuts and bolts of what's going on there, but the reason it's interesting is because all this architecture just makes development easier and faster and more reliable. And I think that trend is continuing. Now, what blew me away most recently, so I used to do all of our coding when we first started, and then I got out of it for the most part. And we have 3 people full-time doing software dev here now. But to help push out some pretty high impact projects, I jumped back in and started coding, and now we're using Copilot AI offered by Microsoft through GitHub. And it's so interesting how different it is to code now, because I will type a comment in my code editor, Visual Studio Code, and then Copilot jumps in and pre-fills and says, here's what I think you want to do. And it can do remarkably complicated things. And it doesn't get it right all the time. It's maybe right half the time, maybe a little less. But it turns into this kind of pair programming process where you say, here's what I want to do. It fills in. You say, yes, that's right. You're reviewing the code that an AI generated. Or you fill it in and it's like, no, it's not quite right, and you fix it. But it's just in the infancy. What really jumps out is that when you combine all of this architecture automation for getting deployed code in front of the customer, which could be internal customers like the shop or an external customer, you combine that with AI that can generate and test code against a spec. And I think the barriers for entry for doing custom development are just going to drop and drop and drop and drop until finally, maybe in the next 5 or 10 years, any shop can just plug into different software platforms online and develop code on the fly. And a laser operator could do that. So right now, the process is the laser operator points out a glitch. And so the software team comes in and can see it and they can fix it, whatever. What if the laser operator could just say, hey, there's a problem with this. It's not right. Describe it to the AI. The AI plugs into the code, pulls up the building block that makes that thing work, identifies the problem, tests a fix, and then deploys it. And then the operator just right then and there can say, oh, yep, that's better.
Right.
All of a sudden, your skilled operators they're not skilled because necessarily they know how to finagle a machine and get it to cut just right, although that might still be a piece. But they're expert operators because they understand process and can actually work with an AI to write new software. I think that's going to happen, and probably sooner than we think.
Yeah, and I think this kind of dovetails. I mean, in the magazine, we've talked about low code apps where we're seeing some shops where the business development person or vice president of sales or some other person in the office who has initiative looks at, all right, we've got certain low code app tools in Microsoft Power Apps, I believe it's called. And if you will, they're they're very basic tools that draw on database technology like SQL or whatever. And one shop I know specifically is actually developing a scheduling platform on it for certain kinds of repair. It's not necessarily metal fab, but it's kind of a truck repair site that they never know what's coming up. And so I cover them because of there's no way to know what the job will be until they have the job in house. So it was kind of that unknown demand that a lot of job shops face. And so what this guy did was develop this basically drop-down menu scheduler that actually automated some scheduling aspects. It was very basic and rudimentary. So we're not talking about Monte Carlo analysis or anything sophisticated, but the fact that he was not a coder, that he came from the sales side, I believe, and he kind of migrated over and can learn this on the fly. How far are we from that? From all right, somebody in sales, somebody in operations, somebody who's been at the fab shop and knows fabrication very well can go in and go, okay, I'm going to teach myself some coding, and with the help of these AI tools, I can write a program sooner than I thought.
I think we're really close. First of all, I think we're in the infancy. The fact that a shop owner can do what you just described at all is actually really incredible. But truly, we're in the infancy. So part of the complexity, part of the thing that makes it hard for this to happen in practice is you need the environment, you need the scaffolding that allows it to happen. And so I described this hypothetical scenario where a laser operator could get on and say, there's a bug, I need to fix it. Well, that opens a bunch of questions. What code are they actually modifying? And what can they modify? And how does that affect other operators who are working on it? So there's some process questions around that. And then on the flip side, I described kind of loosely and in a not well planned out way, but I described what our stack looks like and how our deployment architecture looks like. All that still has to exist. At some level, you need somebody with the skill, the DevOps skill, to go in and say, this is the server architecture we're going to use and all this. And then once you have all that, now the AI needs a way to actually push code in that environment. So all of that we call just the scaffolding. You need the scaffolding to support everything. And even today's AI could work in an environment like that, provided that the scaffolding exists. So where does that scaffolding come from? Well, you described Microsoft's environment. What did you call it?
I believe it's called Power Apps, though. I may be wrong about that. I'm not sure, but
so that's a service, and if you're using that service, you don't have to worry about the tech stack per se. You don't have to worry about setting up and managing a database or building a continuous deployment and integration environment and that sort of thing. But that's going to be the key, is you'll see a whole bunch, and there are already companies like this, tons of them online, right, that actually provide the scaffolding, and you can drag drop something and give it some specs and say, this is what I want this building block to do. And then the AI can go write the code for that. And then the nice thing is, once you've got all that architecture set up and the test, everybody knows that AI gets it wrong sometimes. But if you have a way to automate the test environment and plug it in and fully end-to-end test a system based on a set of functional specs, then AI can deploy into that test environment and test the code it just wrote. And if it doesn't work, the system, the scaffolding that we're talking about, could feed it back to the AI and say, no, this doesn't work. Here's the error I got, or here's the unexpected behavior. And then the AI can iterate. And the cost of iteration for an AI is functionally zero. So maybe it takes the AI 1,000 tries, but in the end, it gets something that meets the spec, and you're done. So it'll become, I think, an art of developing the specs and making sure you've defined it in the right way and iterating quickly and effectively.
I think, just to jump in here, but, you described two scenarios, one where you have the scaffolding in-house, the stack in-house, and then the other where you use an outside service where it's a cloud-based platform so how far can those outside service providers get so that shops don't even need to have the internal scaffolding inside their four walls, versus the advantage of having that inside so that you can at least have your own architecture and have something to build off of, which is the approach you've taken.
Yeah, in the limit, eventually I think there will be no functional advantage to owning the whole DevOps stack. You'll be able to find a service that does all the hosting and takes care of all the complex server management and just makes it easy. And because DevOps it's kind of this, people might not understand what that is, but people say IT loosely and they think that means like a software developer or your Wi-Fi guy, or, you know, but really IT is different from software development, is different from DevOps. And there's a lot of different skill sets in there. There will always be a need for these high-level DevOps engineers that can go and set up an entire stack in the server infrastructure and everything else and understand the trade-offs and different architectures. But those people are going to be employed by the companies that are making these tools that allow you to just plug into a pre-existing environment and write a custom tool that does really effective work. We own our entire stack and we like it, but I think that advantage today is going to potentially become a liability in the future when all of a sudden all this custom software that we're writing today to make us really unique, that won't be unique anymore. Every other shop will have that same capability using these platforms that are starting to age and mature right now.
What will be the role of getting data from the machine when you have this? Because I'm actually at this moment writing a story on micro-tabbing and nesting. And there are all these different, and I'm talking to a shop that has both automated punch with automated part removal, as well as a automated laser with forks that come in and lift the cut parts out. So they really have to pay attention to where the micro tabs are, keep their slats clean, note where the slats are. These slats in particular have a little taper to them, so they adjust a little bit so that you don't cut along. Even if your bed line is over a slat, it's not always over a slat if it's a long straight part, because the slats go off a little bit.
That's a good idea.
Yeah, it is a good idea. And but it's all integrated. That data is integrated in the software. And over the years, they've learned tips and tricks, and they have really expert engineers that know how to take advantage of that. And they have years and years of experience, and that's the value of their programmers. But then I see this and go, wow, getting all these details into a software solution that can automate programming and optimize the programming for automation, so that you do not, because the big reason we don't see automation in more shops is that the static nest development, you need to have the volume to develop that static nest to create a specific environment where, all right, the grippers are going to come in and take these parts out and take these parts out. This is exactly how you're going to stack them out. That's starting to change. We're starting to see more dynamic nests go into the automated part removal. The customer mix defines the fabricate and the parts and the demands and the edge quality and all these little details. Man, feeding that into a customized software solution at every shop, it's just a matter of getting those details from your machines, from your existing nesting software, into a platform that's customized for your shop. I don't know. Am I just rambling off? But
I see where you're going.
Yeah.
I think maybe in a nutshell, there's just all kinds of specialized things that you need. And the question is, can a custom software stack facilitated by AI actually capture that kind of complexity and specificity,
right,
in a per industry? Let me tell you a story. So early on, when ChatGPT came available, and it's better now, but I was blown away by this experience. I actually gave it 2 images. I gave it a picture of a part taken from my cell phone, and it was kind of tilted and angled like an orthographic view on a print. Although it's not orthographic, it's obviously a perspective because it was taken on a camera. But so I take this view and I give it to AI, and it said, is this the same part as this? And I gave it a separate flat panel, and this was a folded part. And it actually was like, no, because it lacks this flange. Like, this is a AI that has no training specifically on sheet metal, but it's like, that's a sheet metal part. I don't think it's this one. I don't think it was produced by this flat because there's a flange missing. Okay, no pre-training on sheet metal specifically on that. And then another similar, and this one is maybe even closer to the point, a common problem is we produce so many parts, it's easy for a part to get dissociated from like a label or something, and then you're wondering what that part is. So the amount of time that we spend hunting for parts is, well, it's too high. And I was kind of wondering, well, could AI possibly fix this? And so I started this dialogue with ChatGPT saying, can you tell me what is this part? And I gave it 10 different part images and wanted to know if it was the same part. And it actually wrote Python code for me that actually analyzed the part and did an image difference to try to figure out whether it was the same part or not. You know, it is actually hard for me to imagine how well an AI might, say, take industry-specific knowledge, like how to make a micro tab and where to lay things out and how to account for slats and automation. But on the flip side, you get somebody who has a depth of experience and just tells the AI, hey, here's what's going on. Here's where the slats are. Can you write me a script that takes the known locations of slats and these particular constraints around automation? And it could actually write code that deals with that. Now, you got to be skilled. You're not going to have just a random person who's never looked at code before figure that out, but it still is a massive accelerator. I think it's only going to get better in pretty impressive ways. And so, yeah, I mean, it's hard to predict, but I don't think that implementing that specialized knowledge is going to be a problem.
Yeah. And in fact, it's going to make that specialized knowledge even more valuable. And in fact, it's going to require, like, the shops who do have those folks with the specialized knowledge, they'll have the superpower of that guy who knows, guy or girl who knows. Again, those who use the data best win. They can go, okay, they can not only integrate, specific microtab strategies with certain material, but they can correlate that with grain direction for bending, a microtab location for back gauging on the brake, or a hidden tab for welding. So why don't we invert that tab so it's a little divot so we don't have to deburr it? There's all these different details. And then that's connected to purchasing. I mean, I visited an OEM not too long ago where, the automation was put to a standstill because they had an alternative material supplier, and they were laser cutting, but they couldn't use the part removal automation because it bowed upward because of the distortion. It wasn't laser flat material. And so with that data set saying, all right, this material from this supplier, this gauge, as this coil set, et cetera, that's not going to work for this automation. If you have that data and pull that data in, if there's a way to break these silos of data down and go, okay, we've got this, and now I just need to feed this into a script to really automate all this minutia to really optimize so that we stop running into these walls and we know the best practice.
Yeah, it'll be interesting to see where it lands, because from the beginning, I've always been of the perspective that a lot of things are better solved from first principles. If you understand, because of the shape of your tooling, and you can do a simulation and actually detect that this bend is going to collide in this way, it's probably better solved in that way from first principles instead of throwing AI at it. That perspective got flipped on its head for me when I realized that, well, the AI can write the first principles check, right? So it is still from first principles, but AI is just getting so good that at some point it's just, every piece of software we write today is influenced by AI because we use Copilot. So, and that's going to become more and more true, whether it's a first principles simulation testing for collisions or not. That's the kind of thing. When it comes to like aggregating all that data, that's interesting too, because AI excels at looking at massive data sets and noticing things about it that might take a data scientist, weeks or more to tease out special relationships. But an AI model that's trained on the relationship of part geometry to scrap rates or actual job costs or whatever else can probably make really accurate inferences just as well as a human can once it has the data.
Right. Fabrication's a game of give and take. Like, for instance, you have this large panel with a large window in the middle that has that for today's lasers, these lasers are so fast that people are doing more slug destruct sequences than ever before. It just makes sense. Just get it through the slats. We don't need to deal with the slug. We don't need to deburr it. We don't need to send it through the deburring machine. So it makes sense. But then, of course, this particular shop had a panel bender. And a panel bender has a mechanism foot that goes down and has to manipulate this sheet right where that window was. And so they had to keep that tabbed in place. But the timing saved because they can make all these bends on the panel bender. It was so the timing on that, the give and take, they said, all right, go put it through the panel bender. That's faster. We'll even have a secondary slug removal after that, window removal and deburring after that, which is a pain in the gazage, but not as much of a pain as trying to form these on the machine on a regular break. So it's a give and take.
See that.
But they only learned that through experience because they said they looked at it going, oh my gosh, that is such a pain to remove that window. Let's put it on the break. And so they tried to put it on the break and they realized, well, this huge window created this bow in the form because it was a flimsy sheet and it wasn't set properly. It was very hard to gauge because it was just this huge window in the middle of the sheet metal panel.
Mm-hmm.
So all these trials and experience led to this decision. Well, imagine putting all that in code. And so that can just, and then you can say, all right, this is one part of 10,000 that we run. And so somebody else who comes across this part can quote it on, let's put it on the panel bender, even though we'll have to deburr this. And it covers all the details on the quoting end. So you can get that true cost.
Yeah, zooming out a little bit, how would you actually implement that? Well, when we quote a bent part, our system actually runs our manufacturability checks across all our service offerings. So we've got a tube laser. Well, it's possible to do a bent like U-channel based out of tube. And there might be circumstances where you want to do that. It just costs a different amount. So we get a part and both of these systems run in parallel and say, can we make this out of tube? Can we make this out of sheet metal? And then expanding on this, we don't have panel benders yet, but we will. It'll say, can we bend this on a panel bender? So it can test all the different incarnations to say, here's how we could build this. And then once you've got those different paths for producing the part, then you run your time models. And this is where AI could potentially be really, really valuable because once you have a bunch of data that says, here's the actual time it took to make all these different parts and these different operations, and here was the cost to run that equipment, the system could back out and build an accurate model for that. So we know we can produce it. Here's how much time we expect to take, and here's the cost. And then you just run those to completion in every different operation, and voila, you've got a recommendation on the best technology to produce the part based on times and models and first principles analysis, all of which could be produced with the assistance of AI.
Yeah, and going back further out of that is it could also give intelligence to CapEx acquisition, be it either tooling or machines. Like, for instance, should I get a panel bender? Well, okay, but what tooling could I get? Can I get horizontal bend tools, which they have, which you can have, you have severe limitations on your flange height with that, but it's like, what's your average flange height? Does that solve your problem? Or should I invest in both? Because that way we have dual routings. So that, all right, if I get this job and that way I have dual capacity for the specific part that's a pain in the butt. And yeah, it's much faster on the panel bender, but it's not that much of a pain in the butt on the brake with a horizontal bending tool that you can just slide in, the clamshells comes up. It's the same mechanism that bends short flanges on a turret press on form tools. So, or rail type press, whatever you have. And so there's all these just minutia there. It's like, man, if you could feed all this in, it could give you kind of a superpower quote that says, all right, here is the optimal price that gives me the optimal margin for this time.
I love this. This will be a bit of an aside, but our vision for where we want to take our quoting is that we understand all the knobs to turn to affect cost. Can we do consignment material? Can we do, could a slight tweaking the design allow for higher nesting efficiency? Could we put this on the automated line? What volume would we need to do that for that to actually make sense? And to expose all that information as closely as possible to the customer. Just say, hey, here's what drives the cost, and you can save this much by doing this kind of a change. So all this AI is a massive enabler for a system like that. but it's also not the end all necessarily, unless it's helping you write the code, because at the end of the day, like, you still need, going back to the beginning of the conversation, you need all the scaffolding. And really, I mean, just talking to an AI and saying, well, tell me the best way to make that part. I don't see a way to get from point A to point B on that one just by plugging into like a pre-existing AI tool. But I see AI allowing us to build a bunch of building blocks that figure out, based on constraints that the developer sets or the shop sets, that figures out how to write the code to enable that front and center technology.
Right.
And the cool thing is that every shop will be able to tailor that to their particular workflow. I mean, for high mix is interesting because it's complicated and there's a bajillion unsolved problems. So it's exciting. But a lot of shops are like making one product. So the idea of having an AI, do all this hyper analysis, it may not make sense at all, but instead AI could be simplifying that particular workflow. I mean, at Oshkosh, this month we crossed $1 million in capitalized software R&D.
Wow.
That's just what we've capitalized, right? So there's stuff that we didn't start capitalizing until a couple of years ago. So we're spending stupid amounts of money on software. Like, imagine being able to have that kind of customization or without like having to spend $1 million. Like, that's what actually gets me thinking. It's like, wow, in what ways is this going to transform how businesses operate when I'll have a whole software team without having a whole software team, right?
Yeah. Well, and I think, you mentioned, about low product mix, and I do often those low product mix operations have what I like to call dinosaur equipment because it works. I mean, the steel rule dies are still being made. So it's for presses. So it's like, why? Because it's the best way to make it. It's there's a paper print. There's no CAD. Why? Art hasn't changed in decades. Hey, that's how it is, and the demand is still there. Software could help there, where you'd reduce inventory and change over and optimize the timing of when you cycle equipment. Let's say it would be the when, the how is set. You're as far as how this is made because it's it's been perfected, but it's the when. I think that I can see that as
perfect. How do we turn this job into cash a lot faster?
Right. Because running via local efficiency is still there at some places where they try to bang out as many parts as you can. It's like software will go, no, you could actually change over more and produce more and optimize your flow for this single part. But a lot of that too, though, you don't need software. You just need some training in lean manufacturing. So there's, I mean, it's pretty simple, but then it can take it to the next level for the low product mix. But I'm more, high product mix is most of U.S. manufacturing anyway, and that's where the biggest gains can be made, and it's where I think we'll see some amazing gains in the future. And just kind of to segue to our next conversation, which will be about cost, about really pinpointing cost. I think that will be truly the next step as far as, all right, once we have all this data and the software is writing the programs for us, we can really know what is truly costing us and what is truly adding value to the customer. So Caleb, thanks so much for your time. We'll see you next time.
Sounds great. Thanks, Tim.
The Next-Gen Metal Fab podcast is a production of Fabricators and Manufacturers Association and part of the FMA Podcast Network. The show is hosted by Tim Heston and Caleb Chamberlain. The podcast is produced and edited by Garrett Slager and Dana Weicker. Additional production support by Dan Davis, Andy Flando, Mike Owens, Billy Culpa, Elizabeth Gavin, and me, Sarah Spring. Thank you for listening.
Pain in the gazage.